Okay. So, last time, like I said, I'd have the grades for us, and I'll have those out to us later today because I have indeed finished grading things. So let's go ahead and go over the quiz. So, first one says, consider the following data, and wants us to find the mean, median, and mode of this data. So, if we look at this data, first of all, we really ought to order it from least to greatest. So that's going to be 5, then 6, oh, whoops, I forgot the negatives. Negative 11, negative 6, 5, 6, and then 10 and 14. Okay, so the mean is just add them all up, divide by the n, or the number of data points we have. So if I add all those up, that's negative 11 plus negative 6 plus negative 5 plus negative 6, whoops, just 5 and 6.
That's the quiz?
Yes.
You send me the answer key. I didn't get the
Did it say quiz 3?
yeah, but like you gave me the answer to it.
It wouldn't have the answers attached. Did it just say answer key at the top, or did you see the answers at the bottom?
I saw the answer.
I don't know how you got that because I don't have that in the computer. Yeah, if you can show me, I'd love to see how that happened. Plus 10, plus 14. We get 18 and divide by the number we have, which is 6, and we get 3. So we have a mean of 3. Then the median, we just find the middle number, and we have two numbers in the middle, 5 and 6, so we need to go for the number between 5 and 6, and that's 5.5. And then the mode is the number that occurs the most, and it has to occur more than once. And well, all of these numbers occur once, so there's no mode. Okay? Any questions on number 1? None? Okay. Bless you. Next one. It says calculate the GPA of a student with the following grades. So this is a weighted mean. So we have a B with a 5-hour course, D with a 4-hour course, and C with a 12-hour course. So what we need to do here for our weighted mean is multiply the value times the weight. So we have 5 hours times the weight B is 3.0, so 5 times 3 is 15. Then D and 4, D is a 1.0, so 1 times 4 is 4. And C and 12, C is a 2.0, so 2 times 12 is 24. And we want to add those together. And this will give us how many credit hours we earned. So 15 plus 4 plus 24 is 43. Now we also need to know the total amount of hours attempted. So 5 plus 4 plus 12. Okay, so 5 plus 4 plus 12 is 21. And we divide these two to get our weighted mean, or our GPA in this case. So 43 divided by 21 is 2.0476, so on and so forth. Scroll down to the bottom. Yeah, there's no answers on that.
No, like, I didn't answer those.
You didn't answer those?
No, I didn't.
Oh, gosh. Someone must have gotten access to the cloud copy. I'll give you another copy. Okay, but we need to round this to 2 decimal places, so we're going to round that to here, which means that this 4 rounds up to a 5. So 2.05. So there's our GPA. Any questions? Okay. Next one, a company has given you the task to research the salary for first-year teachers at the local elementary school. What would you be more interested in looking at, the mean, median, or mode? Okay. So it really depends on what the data looks like. Is it going to be evenly distributed, or is it going to be skewed in one direction or the other? So since this is teachers, and it's their first year, and they're all at the same elementary school, then there shouldn't be a whole lot of difference between their salaries. So their salaries will probably be normally distributed, like that. Okay, which means that mean, median, mode all fall one place. Now in this case, that means that the mean is the one that we want to look at the most, because it actually takes all of the numbers into account when it calculates. Median and mode just look at one number. Okay? So again, because we can expect all of these teachers to be making basically the same salary, we can expect it in a distribution like this, so it's going to be the mean. Any questions? Okay. Next. Oops. So this says for the graph shown, determine which letter represents the mean, the median, and the mode. So letters may be used more than once. So something to keep in mind here is that this is skewed data. This is not evenly distributed like we just saw. So our numbers are not going to occur in all the same place. They're going to occur in 3 different areas. So first of all, this peak right here, where we have a lot of the same number occurring, is the mode. Okay, so maybe this is like 5. This means that we have a lot of 5s occurring. That's the mode. So C is the mode. The median is the middle value. So literally A, the middle value. And B is our mean then. It occurs on the other side of the median from the mode. Any questions there? None? All right. Next, calculate the population standard deviation for the following data set. If necessary, round to one more decimal place than the largest number of decimal places given in the data. So we want to round to, in this case, one decimal place. So, first of all, we need to know the population standard deviation formula. So for population, that is sigma equals the square root of the sum of x minus the mean, or in this case the population mean is mu, squared over n. So we need to know three things for this. We need to know our x values, which we have right here. We need to know our mean, and we need to know our n. So how many data points we have. So let's find that n first, since mean uses that. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data points. That's going to be our n. Next, let's find our mean. So we're going to have to add up all these data points and then divide by 10. So let's see, 6 plus 9 plus 8 plus 8 plus 10 plus 10 plus 4 plus 9 plus 9 plus 37 is 110. And again, we divide that by this 10 and we get 11. So our population mean is 11. So now we have everything we need to plug into here. So first thing we need to do is find our x minus mu, or x minus the mean. So for each of these x values, we're going to subtract our mean. So 6 minus 11 is going to give us negative 5. Okay. 9 minus 11 is negative 2. 8 minus 11 is negative 3. 10 minus 11 is negative 1. 4 minus 11 is 7, negative 7. Again, 9 minus 11 is negative 2. And then 37 minus 11 is 26. Okay. So now we've gotten our x minus mu, we need to square it. So we're going to square each of these values. So 5 squared is 25. 2 squared is 4. We have 9, 9, 1, 1, 49, 4, 4, and 676. Okay, so we've got our x minus mu squared. Now we need to take the sum of all of those. So add all of these numbers up. So let's see here, 25 plus 4 plus 9 plus 9 plus 1 plus 1 plus 49 plus 4 plus 4 plus 6, 76 is 782. So this top part is 782. We need to divide it by n, by 10, so that gives us 78.2, and then take the square root. So the square root of 78.2 is 8.8430, so on and so forth, but we only want one decimal place, so that's going to be 8.8. There's our answer. Any questions? Okay. Next. Is the following statement true or false? It is possible to have a standard deviation of -1. Well, that's false. Because if we look at our standard deviation formula, we have we have a square here, and this square means that anything here is going to get squared, and anything squared is always going to be positive. So we only have positive values in here. It's not possible for us to get a negative value, so false. Standard deviation cannot be negative ever. Any questions? Okay. Last one. So it says calculate the 5 number standard, what am I saying? Calculate the 5-number summary of the given data. So to calculate that 5-number summary, we need to take the median about 3 times. In other words, split this up into quarters. So we're going to first need to order all of this data together. So we have 6, 8, 8, 8, 8, then 10, 13, 14, 15, 16, 17, 19, 20, 20, 22, 22, and 22. Okay, so now I've gotten ordered, we can find our median. So median of this whole set of data is 16, which splits the data in half. Half on this side, half on this side. So now we need to find the median of this set of data, which is 10. The median of this set of data, which is 20. And then we also need our minimum and maximum values. So our minimum is 6 and our maximum is 22. And there we go, there's our 5-number summary. Surprisingly, a lot of people didn't bother to answer this one. And that was what really drug a lot of grades down, was just not answering it at all. Any questions? None? Okay. So grades on this, they were fine. They weren't terrible by any measure of the word, but they could have been better, and I want to see us do better on the next quiz. Okay? All right. So Wednesday, I'll let you work on whatever you needed to work on. And I noticed that a lot of us were having trouble with one problem in particular, and that was the correlation coefficient. Okay? So what the correlation coefficient is, it's a number that measures how closely related two sets of data are. For instance, maybe we're looking at how plants produce seeds, and we're counting how many seeds they produce. And what we have done is we have used days of sunlight as our experimental variable. So what we get is a set of data that's days of sunlight that the plant was exposed to, and then another set of data that's how many seeds the plant produced. So what we want to see is, are they correlated? So does sunlight actually affect how many seeds the plant produces? Okay? So I've got some example data here. Okay, and let's see, I've got x's and y's. X is 32, y is 9.1, and I'll just fill in all this data. Okay. And so again, this could be anything. But what we want to see with our correlation coefficient is how closely related are these? Are they being affected by the same thing? Okay? So this is typically what you'll see when you're given a problem like this, is a chart like this. What I would like for you to do is to make another chart on your own, one that has more space for information. because we're going to be dealing with a whole lot of data points, a lot of values. And it's very easy to get lost with these values if you don't organize them. Okay? Let's see. 1, 2, 5. All right. So I've got a table drawn up here now, and I've got X and Y that I'm going to put in here first. So again, just the same numbers that we had up here. I'm just going to translate them into this table here. So 32, 34, 39, 40, 42. Y is 9.1, 9.5, 9.8, 10.1, and 10.3. Okay. Now we need some extra values in here for our formula. First of all, let's take a look at the formula. This is the formula for the correlation coefficient. R is our correlation coefficient. So the things that we need are the sum of xy, the sum of x, the sum of y, the sum of x squared, and the sum of y squared. More importantly, we need x times y, we need x, we need y, we need x squared, and we need y squared. Well, we already have x and y. So now we just need x times y, x squared, and y squared. And once we get these, we can get their sums. Everybody with me so far? Okay. So, first of all, x times y. This is literally multiply x, multiply y, see what you get. And we're going to do that for each of these rows. So for instance, 32 times 9.1, if we multiply those together, we get 291.2. 34 times 9.5, we get 323. And so we'll just keep on doing that with each of these and fill in the rest of this column. And I've gone ahead and multiplied all of these already. So this one is 382.2. This one is 404. This one is 432.6. Does that make sense? Any questions so far? All right. X squared is just what it sounds like. We're going to take x and square it and write it over here. So 32 squared is going to give us 1,024. 34 squared is going to give us 1156. And we'll keep on doing that all the way down the column. So the next one is 1521. Next one is 1600. And then the last one is 1764. Y squared, exactly the same thing that we just did to x, except now we're doing it with these numbers. Okay? So 9.1 squared, we get 82.81. 9.5 squared, we get 90.25. Next one, we have 96.04, 102.01, and 106.09. Okay, everybody with me so far? Okay. So again, these aren't the values that we're going to be using in our formula. We need the sums. We've got to add them. So each of these columns, we're going to add all the numbers in the column and see what we get. So like for x, if we add all of these numbers, we get 187. Y, we get 48.8. XY, we get 432.6. X squared is 1764. And then y squared is 100. Whoops, I'm using the wrong values there. That should be 1,833. This one is 7,065, and this one is 477.2.
Here's where I had trouble on.
Yeah.
Calculating.
So the next part is the calculation, and what we need to remember is order of operations. So I'm going to go step by step through that with us in just a moment here. And sorry about this, I'm just very, very dyslexic. Okay, again, the numbers that we need for our formula are sigma x, which is 187, sigma y, which is 48.8, oops, y, sigma xy, which is 1833, sigma x squared is 7,065, and then sigma y squared is 477.2. So these are all the values that we're going to need for our formula. Again, here's our formula. And I want to point some things out about it. Up here, we have sum of xy, and we have sum of x times sum of y. Now remember, xy is where we multiplied x times y. And essentially we're doing the same thing here. This is multiply x times y and then get a sum. This is multiply the sum of x and multiply the sum of y. And we're taking a difference between them. So what we're doing here is we're comparing these two numbers. They're essentially saying a very similar thing, multiply xy. Okay, but we're doing it in a different order. So we want to see what the difference between these two very similar ideas is. Yes?
So when you about to put it in, you put x and y in there too? Or you put x?
So this one right here, sum of xy, is going to be this number right here, our literal sum of xy.
And you multiply by the numbers, the amount of numbers that you have here?
No. Oh, the n? Yeah, the n multiply by the data points. So we have 1, 2, 3, 4, 5 data points.
Mm-hmm.
So our n will be 5, yeah. Sum of x is this number right here. Sum of y is this number right here. Does that make sense so far? Do what?
So you multiply?
So yeah, we would multiply these. These are saying they're multiplying. This one is just multiply the n times the sum of xy. On the bottom, we have sum of x squared times n. Don't need to worry about the n for right now, but remember it's 5. Sum of x squared is this number right here, 7065. But this says sum of x squared. So what this is saying is we're going to take sum of x, which is 187, and square it. Again, these are two very similar ideas, but they're done in a different order. So we're comparing what these look like. Same thing with y. We have y squared, sum of y squared, which is right here, minus sum of y squared. So we're going to take this and square it and compare it to this one. So what we're doing here is we're seeing how similar these data points are to one another. How similar is our x and our y? And are they increasing or decreasing or whatever at the same rate? Again, that's what this formula is doing for us. Any questions?
Okay, please calculate it. Please calculate it.
Okay. So now let's plug everything into our formula. Again, we have r equals, and then n is 5 times the sum of xy, which is right there, 1833, minus the sum of x times the sum of y, so 187 times 48.8, so there's our top part. And then on the bottom, we have n, 5, times the sum of x squared, which is 7065, minus the sum of x, 187, squared. And at this point, Hawks likes to split this into two roots. I don't like to do that. I like to keep it one root. And it does not make a difference at all. So times n, which is 5, times the sum of y squared, 477.2, minus the sum of y, 48.8, squared. Okay. So, there's a lot of stuff that we need to calculate here, and it can be very confusing as to what order we go through it in. Remember order of operations. Okay, so let's start with the top part here.
You put the calculator on the
I mean, I guess I can.
it is well, that's okay.
Okay? So order of operations. Let's start with the top part. We're going to do it first, figure out what the total value is of this, and then we're going to go to the bottom part and figure out the total value. So order of operations tells us first do what is inside the parentheses. So parentheses, is there anything inside of any of these sets of parentheses that I can actually do? No, they're just values. The parentheses are telling us what we're doing outside of them. Are there any exponents that comes after parentheses? There's no exponents, there's no powers. So we don't have any like squares or anything like that. Okay, so no parentheses, no exponents. Next is multiply. Do we have anywhere that we can multiply? Yeah. So 5 times 1833. So 5 times 1833 is 9,165. We have another place that we can multiply though, and that's right here. 187 times 48.8. So we're going to go ahead and multiply those as well. So 187 times 48.8 equals 9,125.6. Okay, so that's the top part done. And I'm just going to use this to show that the bottom hasn't changed. Okay? So we've cleared parentheses, cleared exponents, cleared multiply. There's no divide to do up here. Now we can add and subtract. So we'll go ahead and subtract this from this. Now before we subtract it, notice that this one is very similar to this one. They are very close in value. That's a good sign that tells us that maybe our correlation coefficient is going to tell us that our data overall is correlated. But let's go ahead and subtract these. So we have 9165 minus 9125.6. And we get a difference of 39.4. Okay? So that's the top part done. And again, I'm using these two lines to represent that we haven't done anything with the bottom yet. But now that we've got the top done, let's go ahead and do the bottom. So we have 39.4, and it's over the square root, big square root, 5 times 7,065 minus 187 squared times 5, and I should put these in parentheses, times 477.2 minus 48.8 squared. Okay, so this one's significantly more complicated than the top part. And again, we want to follow our order of operations. So order of operations says do what's in parentheses first. So we have a set of parentheses here and we have a set of parentheses here. So we got that set and we have this set. We go to our innermost set of parentheses. So is there anything that we can do inside of this set right here? Or is it just a single value? Yeah, it's just a single value. We can't do anything there. How about here, though? Yeah, we can go ahead and square that. So we can do 187 squared. So if we do that, 187 squared is 34,969. Okay. And why not do this one as well, 48.8 squared. So 48.8 squared, we get 2,381.44. Okay. Drop everything down. And we still have it underneath the root. All right. So we've done our parentheses. Do we have any exponents that we can still do? No, I don't see any. So next will be multiply. Do we have any place that we can multiply? Yeah, we can multiply 5. So 5 times 7,065. 7,065 is 35,325. Okay, so we've got that part, and we need to multiply that as well. So 5 times 477.2 is 2,386. And again, I want you to see this number is very close to this number. This number is also very close to this number. So this is looking good for us for these to be correlated. All right, so we've done parentheses, or we're almost done with parentheses. We don't have any exponents, we don't have any multiply, now we can subtract. So, we subtract these two numbers and these two numbers. So 35,325 minus 34,969 is 356. And this one, 2,386 minus 2,381.44 is 4.56. And so we need to multiply these. Do what? Now, Hawks, at this point, you would have separate square roots. This would look like square root of 356 times square root of 4.56. That's what they want you to do. I want you to know this right now. If you have roots, you can multiply the numbers underneath the root to make them one root. That's why this is the same as this. There's no difference between these two ways of writing it. So we multiply these two numbers together. 356 times 4.56. And we get 1,623.36. Okay, and now last thing we need to do is take the square root of that. So, square root, we get 40.29, let's say 1. Yeah, I'm going to go to 3 decimal points because I want to include as many as I can without having to write too much. So, 40.291. Okay, so there's our bottom. And remember our top was 39.4. Again, how close are these values to each other? They're pretty close. So when we divide them, 39.4 divided by 40.291, we get 0.97788858802, so on and so forth. We want to round that though, and I'll round it to 3 decimal places since I rounded this to 3 decimal places. So 0.978. And there's our correlation coefficient. Okay? Now, again, these are very similar to each other, aren't they? In fact, if these were the same number, if we had like 40 divided by 40, what would that come out to be? 1. Good. The closer this correlation coefficient is to 1, the more correlation there is between our two sets of data. So again, if we were thinking about this as like plants and days of sunlight, so this is like seeds they produce and this is days of sunlight they get, then because they're so closely correlated, we could say that days of sunlight affects the number of seeds that are produced by a plant. Because, again, this is a really closely correlated data. Does that make sense? Okay, good. All right, but I think that will do it for today. So I'll see y'all on Friday, and I hope you have a good day.
I can take it enough.
Sure. Do you want me to send you this as well?